So anyway, question 8, a simple random sample of birth weights of 30 girls has a standard deviation of 829.5 hectograms. Use a 0.01 significance level to test the claim that the birth weights of girls have the same standard deviation as the birth weights of boys, which is 660.2 hectograms. Assume that a simple random sample is selected from a normally distributed population. So a couple things that we want to get out of this first. One is what our claim is, but they did, this last bit that they mentioned is addressing that they have satisfied, this case does satisfy the underlying requirements of hypothesis testing involving standard deviation. So we have our claim, which is the standard deviation of girls is equal to the standard deviation that they gave us for boys, which was 660.2. And then the opposite or negation of that is that the standard deviation then would not equal 660.2. So we can come over here, write our null hypothesis and our alternate hypothesis. It's standard deviation in the claim, it's standard deviation in the hypothesis statement, 660.2 in the claim, 660.2 in the hypothesis statement, and in between them in the null is equals because it's always equal in between in the null, and then the inequality, the strict inequality goes in the alternate. So there's our hypothesis statement using proper symbols, but again, we're going to do a little bit extra here to help us with writing the conclusion. So the R next to the null, the S right below that, and which one of these looks most like, if not identical to the claim, that would be the null hypothesis. So I'm going to star the R. So when it comes time to writing the conclusion, we're going to talk about whether we reject this claim. We may have the evidence, we may not have the evidence. That's what we're about to find out. So next, in part B, identify the tail of the test. For that, we look at the inequality in the alternate. This is a two-tail test. Our alpha is our significance level, that is 0.01. And then our sample information, we were told that they had 30 girls and the sample standard deviation from those girls was 829.5. All this allows us to go ahead and write our rule of rejection. We're going to reject null hypothesis if the p-value less than or equal to whatever our alpha is there, 0.01. So at this point, we're ready to go over to statdisk to find our test statistic, which I just happen to know is chi-squared. If you don't happen to know it's chi-squared, don't worry, statdisk is your friend. It will tell you that it's a chi-squared. And that, as well as find the corresponding p-value. So let's head on over to statdisk. We're going to go analysis, hypothesis testing, standard deviation, one sample. And when we bring this over, it was a two-tail test, the not equal case. Our significance was 0.01. Our claimed standard deviation, which is also the number that's in the hypothesis statement, that's 660.2. our sample size was 30 and our sample standard deviation was 829.5. So we can go ahead, hit evaluate. Then we can also go ahead and hit plot to kind of just help us put this into perspective here. So this was a two-tailed test. We see our red vertical lines in the plot, which is our critical values. So if we were to fall off in either of those tails, our result would be significantly high or low, far enough away from what we would expect if the true standard deviation was that 660.2. And it turns out that our test statistic falls in between them. It's not far enough away. Over in the dialog box, and I'll just take that information back over to here. So let's see if it'll paste right there for me. Wonderful. So there's our test statistic. There's our p-value. So 45.780, and the p-value 0.0493. And is 0.0493 less than or equal to 0.01? No, no it is not. Well, we would have rejected the null if it was. It's not, so we don't. So we fail to reject the null hypothesis. And when we fail to reject the null hypothesis, that means we don't have the evidence. So to keep the phrasing consistent with how you'll see it, we have insufficient evidence to, and then next goes back to what we did up there. It was R, so we have insufficient evidence to reject the claim that, and what was that claim? The birth weights of girls have the same standard deviation work eraser. That's better. As the birth weights of boys. So we put the conclusion together in pieces. Now let's go back, read it from start to finish. We have insufficient evidence to reject the claim that the birth weights of girls have the same standard deviation as the birth weights of boys. So we can't say that these things are different. Our sample result wasn't far enough away from that 660.2 for us to say that population-wise a difference exists. One other thing before I throw it over to Mark, to be careful about. We are working with different alphas. We probably got into such a habit from the beginning of the course of 0.05, 0.05, 0.05. If you make this decision off of 0.05, you're making a different decision. Be careful. And again, there is a method to the madness here of why I have structured it out this way, why I'm having you identify the pieces I'm having you identify up here is so when it comes time to use that information, you've already written it down and hopefully it's registered with you that if it's not a 0.05 case, then don't write 0.05. I've had too many people not write anything up in part B and then write the wrong number down in part C. Mark, anything you'd like to add?
My only two statements were very prescient of you to point out the 0.05 business, because in my class I call 0.05 the magic stats number, which I realize makes you sick to your stomach probably a little bit, but we use it so often that it's something that I really try and drive home. So you do want to be mindful of that. My only other statement was just look at how similar this process is to what we've done previously. In particular, I had a couple of students email, Gary, if you would scroll up just a little bit and look at your part A. Just as a quick reminder, we write out the claim and the opposite, or as I call them, the claim and the negation. Remember that the opposite in this case is the one that doesn't contain equality and therefore goes in the alternative. It's not that we make the opposite or the negation always in the position of the alternative hypothesis. What we do is we choose the one that doesn't contain equality. So if you are a company who, I don't know, sells travel, which is terrible right now. So if let's say you're a travel agent and you want to make a claim that the majority of Americans are comfortable traveling under the current circumstances, you want that to be in your claim so that when you go down and you make your final conclusion, you are either having sufficient evidence to support that claim or insufficient evidence to support that claim. This is more of a statement about test design, about what's the word I'm looking for, Gary? Experimental design. Thank you. I don't know why that took so long to get there, but we can set our claims up in such a way that we are always talking about support or lack of support for that claim. So note that
one that we're going to do is going to work like that.
Okay, so pay attention to that next example then to kind of get a little more of what I'm saying there. But just keep in mind, it's not that the negation always goes in the alternative. It's that between the claim and the negation, the one that doesn't contain the equality case goes in the alternative. That's the kind of fine point that I would point out there for my own students.
And one last thing I want to point out. We were in the two-tail case here. We do have, now just because he didn't program in the Greek letter doesn't mean that we can't put in the Greek letters. But we do have the confidence interval down here. And what we see is we see the range of values that would be consistent with this sort of result. So the standard deviation based on this sample, the population standard deviation based on the sample could be all the way down to 617.5 or as high as 1233.2. So there's quite a bit of range there. And this is why we go through the process, because for most people just looking at 660.2 and 829.5, they would think that those numbers are a long way away. You know, if you're thinking about this in terms of money, there's a pretty big difference between about $830 and $660. But we can't let ourselves fall into the trap, because when we are projecting on to whether or not these appear to be different or not different, it's basically how we feel about it, and it's not about how we feel about it. And again, a lot of with probability is not intuitive, and that's why we do have to run through this process.